For this demonstration, we will use a simple setup for holographic reconstruction. The assembly consists of a focusable beam expander laser module, a rotating polarizer with an attached aperture, the ERIS-1.1 SLM, and a magnetic display mount. Start the HOLOEYE SLM pattern generator software. Now click the File menu and select CGH Computation from Image File. Open the Signals folder and select an image. We use the HOLOEYE's logo. Click Open. At the following menu, you can change the size of the output image and set the size of the calculated hologram tile. For now, we leave it as it is and click OK. The following window shows a preview of the calculated hologram, which is automatically addressed to the SLM. As we use the Spatial light modulator in default configuration, the reconstruction does not look optimal at this point. To improve the output, we use the HOLOEYE SLM Configuration Manager software. Connect the USB UART connector of the SLM with an USB port of your computer. Start the ERIS-1.1 Configuration Manager software. The software is now searching for a connected HOLOEYE SLM. Once the SLM is found, click OK. If more than one SLM is connected to the computer, select the correct one at the top selection box and click OK. The software is now reading out the current configuration of the connected ERIS-1.1 SLM device. Select the Geometry tab at the top. With this option, you can adjust the output image in horizontal and vertical direction. Now select the Calibration tab. Click the Load from File button and navigate to the folder which contains the configuration files. These files are typically provided on the USB flash drive, which is delivered with the SLM. Open the Configs folder and select the proper folder for your ERIS SLM version. Now choose the wavelength you intend to use. We provide two sets of configuration files. The first set is the standard one and is optimized for 60 Hz. The second one is optimized for 120 Hz. We use the standard configuration and select the file for 2.0 pi configuration. Click Open. The Configuration Manager software is now loading the new configuration files. This may take a few seconds. To make the changes permanent, click in the Save to SLM button on the bottom left. In our setup, we use a slightly converging beam to have a sharp focus at the diffraction plane. If the reconstructed image looks blurry, make sure the beam is properly focused. To use the SLM for phase-only modulation, the incident polarization has to be along the director axis of the LC molecules. For most HOLOEYE SLMs, it is along the long display axis. Any other incident polarization would lead to undesired cross-modulation between phase and amplitude modulation. Some HOLOEYE SLMs have an aperture on the display. If you illuminate the aperture, you get a visible noise at the 0th order. Please avoid illuminating the aperture. The ERIS-1.1 offers 4 different modes of operation: an 8-bit and 10-bit mode at 60 Hz, and an 8-bit and 10-bit mode at 120 Hz. We currently use the standard 8-bit mode at 60 Hz refresh rate. To activate the 10-bit mode, go to the Video Signal tab of the Configuration Manager. Make sure to have HDMI selected as a video source. Select the color channel to be used for the lower 2 bits. Currently, 2 combinations are supported: the red channel for the 8-bit input and the green channel for the lower 2 bits, or the green channel for the 8-bit input and the blue channel for the lower 2 bits. Open the Pattern Generator software. At the Output Signal Modes menu, select the correct combination of color channels, which was set in the Configuration Manager. In our case, we select green and blue. To use the 10-bit mode with the HOLOEYE Display SDK, there are pre-selection strings available. In the SDK Examples folder, use the sample code from the file Pre-selection String Examples. Navigate to the line starting with Must be used with ERIS 60 Hz. The following line of code is commented out. To activate the code, remove the hashtag. The code is already configured to work with 8-bit green color channel and the lower 2 bits on the blue color channel. The 120 Hz mode can be activated using the device detection of the HOLOEYE Pattern Generator software, the SLM Slideshow Player software, or the SLM Display SDK. Now start the Configuration Manager again and go to the Calibration tab and load the proper configuration files for 120 Hz. The default mode for the ERIS 1.1 at 120 Hz is 10-bit. This works best for most cases, even if your input functions only use 8-bit phase values. At the pattern generator software, use the Output Signal Modes menu to set 8-bit if required. At the HOLOEYE SLM Display SDK, you can set 8-bit mode as shown in the preselection string examples sample code. To overcome limitations of the HDMI chipset, the ERIS 1.1 uses two color channels of a 960 by 1200 pixel HDMI input signal to address two physical pixels on the SLM. The red color channel is used to address all odd pixels, and the green color channel is used to address all even pixels. By stacking the pixels, a 120 Hz output at the full resolution of 1920 by 1200 pixels with 8-bit phase values is generated. At the 10-bit 120 Hz mode, 2 bits of the blue color channel are used in addition to the 8 bits of the red and green channel. To use the 120 Hz mode, your input images or functions must be converted to the required 960 by 1200 pixel input format using the 3 color channels. This is done automatically if you use the HOLOEYE Pattern Generator software, the SLM Slideshow Player software, or the SLM Display SDK. The SLM is now properly configured.